Got another little project for today, and this here is one of my workbenches, which I just put on wheels, and the top's off of it now. But it has a large cabinet under here with just one shelf on the bottom. Really never had that much in there. So what I'm going to do is turn that section into an air compressor. Now, one of the reasons why I never use any kind of compressed air in the other shop was I just had one of the, I believe it was a Cobalt, one of those oilless reciprocating compressors that was loud as all hell. Plus, it actually ended up breaking. It was like the couple of years that they had digital controls in there, and the circuit board went. And the replacement part was like $120, but I only paid $150 for the unit, so I just never got it repaired and never used it. So what I'm going to do is I'm going to use a refrigeration compressor. Now this compressor is pretty much brand new. This was in a unit. Now I've had this sitting around for a while because I've been meaning to actually do this and just never got around to it. But this was in a unit for maybe a month. Another company had come in and replaced the compressor, and they were still having problems with the unit. And we went in and took a look at the unit and just said the unit was just junk. It was all rotted out. The evaporators were garbage. So we suggested to them to not even bother putting any more money into it and just get rid of it. So before we gave them a new unit and we removed their old one. And before we junked the unit, I had ended up taking out the compressor. Now this is a 2000 is the date on this compressor, and like I said, it only was in there for like maybe a month or so. And this is a 134A medium temp compressor. It really doesn't make a difference. The only thing is the refrigerant oil in this is polyester, which is kind of tends to absorb moisture. Most newer compressors are the synthetic oil like that in it. There's mineral oil was R22, R12, 502, which is refrigerants that they don't use anymore. So most everything has the poly oil in it. So just be aware that it does tend to absorb moisture, which is not necessarily good for an air compressor, but we'll have a way of getting around that, which I'll show you. So we're going to use this here. This right here is the discharge line. This is where the air is going to come out. This is what's just called the process tube. All this is for a gauge port. We can use this for an oil port now to refill the oil. And back here, which you can't see, this little tube right here is a suction line, and that's where the air is going to go in. We'll put I'll figure out some sort of air filter on the outside of this. Now obviously I'm going to need some sort of storage vessel for this, and what I've got, now I'm doing this with all found parts. There are a couple of pieces that I had to buy, which I'll show you, but most of this is stuff that I've had lying around forever and a day, and stuff that I've salvaged. So what we're going to use for a storage vessel is this. And what this is a very old recovery cylinder that was sitting in the depths of our shop. It didn't have any refrigerant in there, but I did turn it upside down and let it sit for like a week, and I did get some oil out of it, so it was definitely used at one point. Now this is the smaller cylinders. Usually the bigger ones look like about the size of a propane tank. As you can see, this is a little bit smaller. And this is very good for this application because we have two ports. Let me stand this up here and zoom you in. Okay, what we have is we have two ports. We have this one here, which is the liquid port. This one here is a vapor port. Now this port here, this actually has a dip tube that goes all the way down to the bottom of this tank. This one does not. Its outlet is right here. Now that's good because no matter what I do, and there are going to be ways I'm going to be able to mitigate it a little bit, but no matter what I do, some oil is going to come out of this compressor. It's just the way refrigeration compressors are meant. They're meant as a closed system. The oil mixes with the refrigerant gas and gets pushed throughout the system and recycled back to the compressor. So I mean, there's no way I'm not going to be able to prevent at least some oil from coming out of that compressor. So if it does go in, which is our air is going to come in here, it's got to go all the way to the bottom of that tank and collect on the bottom of the tank, and hopefully not make its way back up the vapor tube, which is well, it's not even a tube, but the vapor port, which is all the way up here. So that's one way that we'll kind of collect the oil in this tank if it does come out. The other thing that's good about this tank, and because it's so old, you can see this port here. A lot of tanks don't have this anymore. What this was for pressure gauges, and also they have, when recovering was required, you know, before you didn't have to recover refrigerant, you could just vent it out into the air, and then the EPA came in with requirements where you had to recover it and everything else. That was in 1992, I believe, if I'm right, 1991, 1992. You can double check that on me, I guess. Not really, I can't really remember, but anyway, it meant that you had to recover refrigerant. Now, these cylinders can only be filled up to a certain amount. They can only be filled up to 75% capacity, and even less than that depending on the refrigerant type. But you could do it by weight. You tear the cylinder, weight the cylinder, and then fill it up, do it by refrigerant weight. Or they had kind of newfangled recovery machines at the time that come out where they would automatically shut themselves off. And a lot of times they use, these ports had some sort of electronic sensor. I had like a liquid float in there. That's why the older tanks had this. I haven't really seen a newer tank that has this, but this is good for us because that gives me a port. I'm not going to use this one, but there's a smaller one back here that does not have a Schrader in it. This one does have a Schrader, which I'll cap off. But this back here gives us a port to be able to put my pressure control that's going to cycle this. Also on the back of this, which I can't show you because of this guard here, but just like a propane tank, it's a pressure relief here. And just like a propane tank, it's one of those screw-in pressure reliefs, so the less pressure that you have on that spring, the lower the pop-off value of this is. So I can actually adjust that to get a pop-off value of what I want this to come out. I'm only going to have this go up to like maybe 175 to 200 psi anyway, and these tanks could take a lot more than that. So that still gives me a good safety check too. The only thing that we're going to have to do, you could actually use some sort of other tank that you have for this. You could use a propane tank, obviously, with all the gas removed, and you're sure that all the gas is removed, or any other kind of cylinder like this. But the one problem that I'm going to have with this is going to sit upright, just like it is, but unlike a normal compressor tank, I don't have any kind of drain on the bottom, which is very important because moisture is going to collect in this, and obviously you don't want it to rot out the bottom of the tank. Don't worry about that little rust spot. That's just surface rust from scratching the paint off. So I'm going to have to make a drain for this. Now I do have right here the compressor drain right here. It's just one of those drain cocks that you see on pretty much most air compressors that you can get. And it's a 1/4 inch NPT thread, but the problem is obviously if I just drill and tap the bottom of this tank and solder this in, this is going to be above the rim of the tank. So I need this, the end of this, to be lower than the inside lip of this tank to be able to drain any of the water out. So what I'm going to do is I'm going to drill a hole in the bottom of this tank, and this tank is pretty thick, but I'm going to drill a hole in the bottom of this tank. We'll clean this up, we'll go on the lathe, I'm going to turn myself a slug with a little lip, thinner, slightly thinner than the thickness of this metal here, and a nice snug fit in that hole. And I'm going to drill and tap it for the 1/4 inch tap. And that tap, I'm going to make sure that the end of this does not protrude into the actual area of this tank. So in other words, it will be below. And then I am going to silver solder that that slug in place. Now, that's perfectly fine. It's not going to In other words, it's not going to explode. It will definitely hold its pressure. Silver solder and things like that are used extensively in refrigeration systems, which have discharge pressures in excess of 250, sometimes even 300, and even up to, on the new 410A systems, could be up to 600 pounds of pressure. So that'll definitely hold it if you get a nice good silver soldered surface in there. That'll be more than enough to hold what the pressures I'm going to be working at, which is probably 175 to 200 at the very, very max. So that's the plan with this. Now, to shut that compressor off on pressure, I have an old high pressure refrigeration high pressure control, and as you can see here, it's adjustable to whatever I want. And this is pretty much brand new. It's just been kicking around the truck forever. That's why it's all scratched up. This actually came on a brand new condensing unit, and we had changed it out for a dual pressure control. So I had a low pressure and a high pressure together. Instead of having two controls, have one in the unit. So this has been kicking around in the truck forever, and it just looks, even though it's brand new, the front of it looks like death, and so I can't really sell it to a customer, but I could definitely use it for this application. So there's another found component. Now, the other found component that we're going to have is this regulator, which is a CO2 regulator that I liberated from a Pepsi tonic dispenser. And this is their CO2 regulator that they use to carbonate all the tonic and stuff you see in those soda fountains. So as you can see, we got, let's see, what's the max on this? Max of 1800 psi. Actually, you can even see it says chain CO2 tank right there. And then here is our regulated pressure, which is up to 100, which is more than enough for what we're going to use it for. Now, as far as CFM flow and stuff like that, I don't know what we're going to get out of this. I'm not using this to power air tools. I'm using this to power pretty much just an air gun to use on the lathe, and then also a couple of small hand airbrushes that I use. So as far as CFM goes, more than enough for what I'm using it for. Plus you can pump up your tires in your car too, if you really wanted to. So, and off the end of this here, which is, this here is the outlet. I'm going to have an oil and water separator on the outlet of that, so that we kind of get all the impurities and whatnot out of the system. And this here is the inlet. I already have a piece threaded into there, super tight. All the tubing that we're going to use to connect this is going to be 1/4 inch refrigeration tubing, soft drawn, so I can bend it with my tubing bender. A good old rigid 180-degree bender here. So I'll be able to bend that tubing where I have to go instead of using fittings. I am going to have to use fittings. I'm always going to have to solder it into the compressor, but I'm also going to use, on the outlet of this here, a process tube which gives me a 1/4 inch flare. So that would sit into there like that and give me a point to connect that 1/4 inch tubing. And we're going to use flares. These happen to be what are called swivels, basically solder on flare nuts instead of using a flaring tool and everything else like that, which is perfectly acceptable, and I do have one in the truck and I do use it. It's just I want a really good sale. These are perfect flares, so I don't have a chance of oversizing and undersizing the flare or anything like that. And they're just quicker, especially if you're on a job, and these things work out wonders on evaporators, because usually, especially if you have a leak or something, you got to cut a piece out on the expansion valves. They only give you like a stub about this big, so you can just solder one of these guys right on there instead of having to try to flare out. And use these a lot at work. So we're just going to use those, and to connect everything up, we're going to use soft solder. And I know you're already screaming, soft solder is not strong enough. It's plenty strong. That's one of my actually biggest gripes ever. I think one of the things I get in the biggest fight about at work is that a brazed joint is stronger than a soft solder joint. Not necessarily true. If you're using regular 50-50 pumice solder, alright, that's one thing. But this stuff here, not this. Stay Bright, which is actually a silver bearing solder, this stuff is the shit. Okay, this stuff, first of all, will hold pressure like you wouldn't believe, and is actually stronger in some cases than an actual brazed joint. Plus this stuff, you can control the melting point of this really good, and if you get used to it, you can actually, because sometimes the fittings, especially on evaporators on the end, when you put the pipe in there, they kind of float around in the swedge joints, so you have a little bit of a gap. If you get really good with handling this, you can actually bridge that gap with soft solder, and it works great. The other thing too with brazing rod is you are heating that joint to cherry red, especially with people that braze in expansion valves and stuff like that. Those can't get hot. You just can't get an expansion valve hot. There's too much stuff in there to ruin. So this allows you to solder in an expansion valve or something like that and use way less heat. Also, the other thing with brazing, especially in refrigeration systems, is you have to flow nitrogen to it. Otherwise, you get scale buildup on the inside, which flows throughout your system. Also, even if you're using fittings, by heating that copper up to cherry red and then having it cool down, you basically just annealed that copper fitting. So instead of having two pieces of hard drawn copper into a nice hard 90, now you have floppy soft copper everywhere that can easily bend. And even though you braze that nice joint in there, if you're not careful with it, you trip on something, you hit something that you're not supposed to, or something's not supported right, you can kink that right in half. It's just, anyway, that's my rant about brazed soldering. So we're going to soft solder everything, and I can guarantee you a solder joint is not going to let go. So first things first, I want to drill a hole in the bottom of this, and pretty much it's an arbitrary size here. I got 1 inch, I think I got 1 inch, yeah. I have 1 inch round that I'm going to use to create the plug and the boss for the drain fitting. So we'll probably drill this out to, I don't know, a little bit over ½ inch, maybe about 5/8 or so, and then we'll turn a small shoulder to be able to fit right inside this. That'll locate the slug. It will drill and tap the slug for the 1/4 inch pipe thread. So let me drill this here. Now I'm gonna have to do it freehand. I'm gonna have to do it with the drill because this is not gonna fit in my drill press. So I'm gonna have to do it with the hand drill, and I'll just figure out where the center of this is, mark the center, give it a center punch, and probably use 2 different sizes of drills, and we'll get that in there. So let me go do that, and I'll show you what we come up with. I'm zoomed way in here. I got the hole drilled, and I followed it up with an adjustable reamer to round it out, making sure it's as round as I can get it. That right there that you see, that's the dip tube. That's the part that's hooked up to that red valve that goes all the way to the bottom of the recovery tank. What that's for is for liquid refrigerant. Basically, it would empty all the liquid refrigerant into the bottom of this tank. That's what that's meant for, to separate liquid and vapor. So like I said, that gives me a good long tube in here to condense water and empty out the oil directly into the bottom and take it out of the airstream. And this right here, let me zoom out a little bit here. As you can see, it's right in the center of the tank there. And I drilled it, and I used an adjustable hand reamer in there and widened it out to just shy of 3/4 of an inch, and it's pretty consistent. So we're looking at $740, 739, 742. So we're within a couple of thousandths around the edge there. So what this thickness here of the tank itself, I measured the outside thickness. It's all the same metal. We're roughly, depending on where I measure it, between 85 and 95 thousandths. So I'll probably make the little lip there probably around 70 thousandths or so, to make sure we're below the metal on the inside, so that way there any water that condenses will be able to come into the piece that I'm putting in and drain out that drain valve that we have. So that's the plan. So let me set up on the lathe with a piece of 1 inch is what we're going to use, and we'll cut it to fit. Okay, so we're pretty much set up for this. We have our 1 inch piece in there. It's already faced off. I have my dial indicator set up on my carriage, so what I'm going to do is I'm going to come to the edge, touch off, I'll set my 0, and we're going to go in, I was getting around anywhere between 80 and 90 thousandths of thickness on that tank, so we'll probably go in about 70 thousandths just to be sure. So we'll cut into a little shoulder, 70 thousandths by just shy of 3/4 of an inch, 740 thousandths on the actual diameter. Just like, you know, a couple thousandths under that to be able to fit it into that hole. So we'll probably go somewhere around 735 or something like that, just so we have enough to, we know that we're in there. And that's pretty much it. I do know one thing though, trying to get these shots in here. I got to rig up some sort of overhead kind of camera system here. Just, you know, the tripod on the benches with these lower ceilings is kind of becoming a pain in the ass, so excuse the quality of the, you know, shots on this one, but I'll figure something out there. So go in. Set the 0 on that carriage indicator here. And I set 0 on my dial. Took a couple of light cuts just to make sure everything was good. We're looking good, so we can take deeper ones. that should pretty much be our diameter. I'm gonna double check. It's 740 exactly, so we'll take a couple off. Take another 5. Now we should have enough to get that in there nice. $730, $733. Okay, so that's plenty good. I'll just break the inside edge with a small file. And this outside edge, what I'm actually going to do is and break that edge. I want to give a good bit of a relief in that cut, because what I want to do is make a little bit of a lip, so when I braze it I have an edge to everything to suck in nice and nice. Everything's going to go in under capillary action, but if I can just give myself a little bit of a start, and then what I can do with the silver solder is kind of bridge that gap around and make it almost look like a weld. Okay. Now, what we'll do, bring up the tailstock. Kind of getting used to where everything is again. Center drill ourselves, pull this tailstock back a hair, and we're going to drill our tap size for our quarter inch tap. So, which is for a non-tapered hole is 7/16, which is what we have here. And I'll just drill this all the way through. Okay. Okay, there's the hole, and here's our piece. There's that lip that we cut, and there's our thread. So this will fit right in there, nice and snug. And then our drain here. Oop. It's nice and snug in there. Now I have a little bit of putting that chamfer on the end, I have a little bit of space in there that'll be able to suck the solder right in there once I get this nice and hot. And now we're able to drain any moisture or water that we have out of here. And see, I don't know if you guys, it's a good place to show it, but maybe right here. I don't know if you can see, if you can tell there, but the edge of this is below that metal edge. I don't know if that shows up well on camera, but so any moisture or anything it collects in the center of this thing, we're now able to drain out with our drain. And this will protrude out the bottom of the plate that this is going to be mounted to, so I'll be able to reach my hand underneath the entire bench and let the water out. So that's the plan. I'll probably get to silver soldering this together tomorrow because I want to do it outside because in case there's any oil or any nasty shit in there. We'll do it tomorrow, and the only reason why I'm silver soldering this is because pretty much that's the setup that I have. I don't have any kind of welding facilities, but obviously if you do, go ahead and TIG weld that sucker right in there. Okay, so we'll wait till tomorrow and we'll get to silver soldering this together. Okay, we're getting ready to silver solder this here. So this flux a little thinner, it's a little chunky. There we go. It's up around the edges a little high too, so when I hit it, it'll flow around. An oxyacetylene rig would be perfect for this. I don't have one, so I'm using big ass turbo torch.
Okay, now I heated it up really nice, let the solder go in and flow in and start sucking, and then I just made a little edge around, almost like you would with the weld, and puddled it around the edge just to give it a nice little grab. That ain't going anywhere. So I'll just let it cool down, and we'll scrape off some of the scale and see what it looks like. It did run a little bit over there. You can see the flux run. Usually the solder will follow the flux. And like I said, if you put the flux a little bit up on your part, that way there, if you're not exactly poking it directly in that crack where the actual seam is, it'll hit that flux and be able to run down and in. So that should be plenty strong. I'll just let it cool down.